Hey everybody, Trey here. Welcome back to another video. It's been quite the active overnight stretch for parts of the Florida Peninsula where we have seen at least 32 tornado warnings, as well as many reports of confirmed tornadoes, including this one, a very stout supercellular waterspout that came ashore near Clearwater, Florida in the Tampa area just before 2 a.m. Eastern Time. Very stout looking funnel there you see on the top of the image. Here's another shot of it as it came ashore, as well as this one as it moved deeper into Pinellas County, producing some power flashes. So very stout tornado there. That has been the main tornado with this event, but still several supercells within this little setup across the Florida Peninsula, and a couple of which have produced some tornadoes. So this is not a setup we talked a lot about over the past few days. I posted a little bit about it on social media, but it has definitely lived up to expectations, and I thought it'd be cool to do a little brief breakdown on the meteorology behind this setup. So let's go ahead and dive right in. So it all begins a couple of days ago with this little swirl in the southwestern Gulf. I posted about it on social media. This swirl was an area of interest identified by the National Hurricane Center as having a very low chance of developing. Of course, it never actually did develop, given unfavorable conditions out ahead of it for tropical development, but at least it was a little bit of a tropical-esque disturbance situated in the southwestern Gulf. And this swirl, in tandem with perhaps the remnants of former Hurricane Lydia, which rapidly intensified and made landfall as a Category 4 near Puerto Vallarta, Mexico, on Tuesday evening. It quickly weakened as it moved ashore. Its remnants moved off to the northeast and emerged into the Gulf. So the remnants of Lydia, in tandem with this little swirl in the Gulf, were expected to merge with a frontal zone draped across the Gulf of Mexico, and the surface low associated with this activity would move along the front and deepen, developing its own frontal zones as it made its journey toward the eastern Gulf Coast. Fast forward to yesterday evening, and the surface low was situated just south of New Orleans at about 7 p.m. Central Time, 8 p.m. Eastern Time. It continued to make its journey off to the east-northeast, and you can see just a very well-defined surface low, tightly wound surface low, warm front draped off to the east across the north-central Florida Panhandle, cold front down to the southwest. So just a classic mid-latitude cyclone, classic surface low here. And of course, in the warm sector of the surface low, the surface winds had strengthened and backed to out of the south or south-southeast. And of course, we know that is favorable in many cases for tornadic activity in given events. Those effects extended up into the low levels of the atmosphere. Here is the 850 millibar analysis, and you can see a nice plume of about 35 to 40 knots or so out across the Gulf, making its way into the Florida Peninsula by about midnight or so. Even the low-level jet continued to strengthen here going into the early morning hours this morning, about 50 knots there just off the coast. So a very large plume of a favorable low-level jet initially out of the southeast before veering a little bit this morning out of the southwest. That will allow the tornado threat to diminish going into the early afternoon hours. The low-level winds are going to veer as that surface low moves off to the east. But we had a very favorable look in the low levels, at least kinematically, for a tornado setup, given a very well-defined mid-latitude cyclone surface low with a nice wind profile within the warm sector, surface winds, and 850 millibar winds out of the southeast, strengthening and slightly veering with height. Not much to see up at 500 millibars. We have a kind of a complex pattern across the U.S. Big trough here across the west, trough here across the Great Lakes region, a little bit of a ridge in between, and we have a little bit of a trough sneaking under that ridge here across East Texas into Louisiana. Nice belt of enhanced flow across the entire region here, the northern Gulf into the northern half of the Florida Peninsula. So not a ton going on here at 500 millibars, maybe a few little short waves rotating through the flow there. So the overall large-scale forcing for ascent was fairly subtle. Really, the low-level flow, the strengthening of the low-level flow, the forcing from this low-level cyclone was able to initiate these storms in this environment. For the most part, these storms were not really tied to any surface boundaries. They were mostly out in the open warm sector. We had a few along the warm front, but mostly out in the open warm sector to the south of the warm front, and that was due to very strong warm advection. We saw those winds in the low levels out of the south and southeast, helping to really pump that moisture northward, and that warm advection was enough to initiate very spotty supercells out in the open warm sector. We've talked about this a lot in southeast tornado events. You'll often have the main band of storms along the frontal zone to the west, and then out in the open warm sector, you can have these sporadic little supercells that go up, and they tend to be more discrete by nature, given that they're more kind of random within that strong warm advection regime. So the storm mode was likely to be discrete, and we saw plenty of discrete storms south of the main band of rain that was along and north of the warm front. Out in the open warm sector, plenty of room for discrete storms, given fairly subtle forcing in the synoptic scale, and just an overall nice warm advection regime to initiate spotty supercell storms in the open warm sector. Here's a wide view from the Tampa Bay radar starting at 4Z, so 10 p.m. Eastern time, and you can just see a bunch of little supercells out in the open warm sector. Main band of rain off to the north, but just plenty of little spuds, as we colloquially call them in the storm chasing community, little mini supercells out in the open warm sector. These would continue to move off to the northeast, and a lot of them would move onshore. The main one being this one here, the southernmost one, just west of Tampa, moved ashore near Clearwater. This one also to the north produced a debris signature west of Beverly Hills, Florida, and produced some damage up there. And that would continue into the early morning hours. Plenty of little beans here in the warm sector moving off the Atlantic Ocean, off the Gulf of Mexico, onto the Florida Peninsula, with a continuation of tornado warnings into the morning. If we pull up the velocity here, you can see plenty of little couplets here. This is at 4Z as well. Plenty of little couplets there. Really everything was spinning. Very strong low-level flow. Strengthening of the low-level flow helping lead to very strong low-level shear, and so everything really was rotating here, and given the discrete mode, these were likely to produce tornadoes. Of course, the less friction from the land out over the open waters of the Gulf of Mexico helped to support tornadogenesis in these storms, or helped ease the process of tornadogenesis in these storms. So we had likely a number of waterspouts here well off the coast, and then a few of them were able to sustain moving into on land here on the west coast of Florida. Zooming in to the Tampa Bay area and to these couple of supercells down here, the southernmost one here is our Clearwater storm. Clearwater is right in here, and you see this storm, just a very small supercell, but just a classic looking presentation on radar for supercells. You see very pronounced venting of the precipitation aloft, very well-defined hook echo here on both of these storms, really, but this southernmost one would be the one of interest for the Clearwater area, as that would produce the tornado. But just a very classic situation, classic-looking radar presentation, and not something you see super often in Florida, but certainly the environment, given strong low-level shear, would favor. We'll take a look at some soundings here in a second, but strong low-level shear would favor tornadic supercells with these storms, producing a tornado at this point, moving onshore, maintaining its classic supercell shape for quite some time into Pinellas County and eventually Pasco County before things kind of dissipated. Here is the velocity imagery. You'll see as that moves onshore, very strong couplet here, and that is not surprising given the imagery we saw. This was as it was over open water. Very large tornado there, very stout stovepipe tornado there, indicative of somewhat of a strong tornado. Of course, you can't really pick out or determine tornado strength based on size, but most large tornadoes are going to be fairly strong, and the radar data certainly backed that up. Very strong signature here moving toward Clearwater, and that would maintain itself as it moved onshore. Of course, interaction with land hurt things a little bit, didn't last a ton longer, still maintained its low-level mesocyclone for quite a while as it moved onshore into Pinellas County before dissipating by about 2 to 3 a.m. or so. But very pronounced supercell, and no wonder, because here was the RAP proximity sounding. This is at Clearwater from the 6Z RAP, the initialized sounding at 6Z, and no wonder this environment was producing tornadoes. Lots of instability, over 2,300 joules per kilogram of mixed layer CAPE, so instability not a concern. Of course, we don't have the sunshine to help heat the low-level atmosphere to really bolster that instability, but we had very strong low-level warm, moist advection. Those strong low-level flow out of the south and south-southeast helped to really pump that moisture northward into this region. Strong warm advection helped to maintain instability in this environment. Even though lapse rates were on the lower side for tornado events, we'd like to see them in that 6+ degrees Celsius per kilometer range. Definitely the all of these pretty much below 6 degrees Celsius per kilometer all the way up through the atmosphere. But that often doesn't mean a whole lot in tropical environments, especially with these mini supercell environments. It doesn't really matter. As long as you have enough instability, you should be good to go. And these shear profiles definitely favor tornadic activity with these supercells. Lots of low-level curvature, strong veering and strengthening of those low-level winds with heights, leading to strong curvature in the hodograph. Over 200 meters squared per second squared of effective storm relative helicity. So very strong low-level shear in this environment. Strong deep layer shear for supercells, 45 knots of effective bulk shear. Winds at the surface out of the south-southeast at 15 knots, strengthening to 50 knots out of the southwest at about 500 millibars. So strong deep layer shear for supercells. Of course, we had already established the discrete nature of these supercells, so definitely no surprise that these were producing tornadoes given this low-level shear profile. Strong streamwise vorticity as well. We've talked about this a lot before here on the channel. Streamwise vorticity is when your storm relative wind vector, drawn from your storm motion to the point of interest on the hodograph, when that vector is parallel to your horizontal vorticity vector, which is perpendicular and to the left of the hodograph. When those two are parallel, you have purely streamwise vorticity, and you can see that that is the case through quite a deep layer of the atmosphere. Really throughout the entirety of the atmosphere, you see that that is the case. Very strong streamwise vorticity in this environment, especially through the lowest few kilometers. So streamwise vorticity, I've talked about it before. That's like an NFL quarterback throwing a football with that perfect spiral. It's a lot easier for the wide receiver to catch. Doesn't have to bobble it at all to catch it. It's very easy to catch. That is similar to streamwise vorticity. You have these vortex tubes in the low levels. They're already oriented in the right way, and so they just have to be tilted and stretched into the vertical. And given strong instability, especially low-level instability, 3 Cape approaching 200 joules per kilogram, their strong low-level instability was able to stretch that low-level spin into the vertical to aid in tornadogenesis as well. So the streamwise vorticity and strong low-level shear definitely helped this environment out, coupled with strong instability, especially in the low level. So all in all, this is a fairly classic tornado environment, fairly classic Florida tornado environment, perhaps even a higher-end Florida tornado environment. Not often you see this kind of instability coupled with this kind of low-level shear, but this surface low in the Gulf certainly helped things out. As we mentioned, these supercells were quite small in size, and that has to do with the storm relative inflow. The storm relative inflow is basically just the amount of wind flowing into the storm, and that can be represented by our storm relative wind vector, drawn again from the storm motion to the level of interest of the hodograph, and we'll use the surface level here for this storm relative inflow discussion. Storm relative inflow regulates the mass flux into a supercell. So intuitively, the stronger the storm relative inflow, the more mass is going into the storm, and therefore you can get much larger supercells with more storm relative inflow. Generally, above 35 knots of storm relative inflow yields larger supercells. On the other hand, when you have weaker storm relative inflow, that means less mass is going into the storm, and therefore you are often going to see mini supercells, especially with storm relative inflow less than 25 knots. And you can see here on our RAP proximity sounding, we are definitely dealing with very weak storm relative inflow, maybe there's about 10 knots, so about 20 knots of storm relative inflow there. So very weak storm relative inflow. That means not a lot of mass is going into these storms, and that is why these storms were able to maintain their very small size throughout their life cycle, and why we did not see much larger supercells. Moving on to 8Z, just to show how the environment maintained itself through the morning and continues to do so into the morning hours this morning. This is the Melbourne radar vertical wind profiler from 8Z. So 4 a.m. Central Daylight Time, the Melbourne radar is over here on the east coast of Florida. Tampa Bay is over here on the west coast. So still a good look within the environment for the Florida Peninsula, and you can see that that environment maintained itself through the morning. Very strong low-level shear, strong curvature in the low-level hodograph, 0 to 1 kilometer storm relative helicity as measured by the radar, about 250 meters squared per second squared. So very strong low-level shear, strong deep layer shear for supercells over 40 knots. So certainly a classic-looking tornado environment, and it continues to maintain itself into the morning. This is at 12Z, so 8 a.m. Eastern Daylight Time. Still strong curvature in the low levels, and in fact we increased the low level shear a little bit to about 300 meters squared per second squared of 0 to 1 kilometer storm relative helicity. So strong deep layer shear. still in play, and that's why we're continuing to see a few tornado warnings this morning across the Florida Peninsula. And that tornado watch that is in place here, I'll show you that graphic again. Tornado watch in place in the red box through about 3 p.m. Eastern time. So chance for supercells and tornadoes continues throughout this morning into early afternoon, although low-level winds are going to continue to veer a little bit. You'll see, let me go to the current SPC mesoanalysis to give you a current look at the environment. We'll zoom in on the southeast sector, and you will see that those low-level winds have continued to veer a little bit. Low-level jets still very strong. Low-level flow at about 40 to 50 knots here across the Florida Peninsula, but those winds are certainly more now out of the southwest, even west-southwest across the Florida Peninsula. Surface data here, we see all throughout the morning strong winds out of the southeast, helping to really advect those high 70s dew points into the area. So very strong moisture advection in the low levels, but those low-level winds, as you'll see, continue to veer throughout the morning and now sit about 15 to 20 knots, but out of the southwest. So those winds in the low levels certainly veering with time as that cold front and surface low approach. So the tornado threat will diminish going into the early afternoon, but throughout the early morning hours, certainly a favorable low-level environment, including at the surface here, for tornadic activity. So that's going to do it here. Just a little breakdown on the overall event that has gone on this morning across Florida. Certainly a notable tornado event for Florida standards, including this guy near Clearwater, Florida. Certainly a stout tornado and one that caused some damage in Pinellas County there as it moved ashore. So a very interesting event, no question, and meteorologically, certainly perhaps a higher end event for Florida standards as far as tornadoes go. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.